Objective 2 talks about 3 properties of correlation. So the first property says correlation makes no distinction between the explanatory and response variables. So again, it doesn't matter which one is your x, which one is your y. And if you look back at that formula, the z's were right next to each other. They were being multiplied. So it doesn't matter if zx comes first, zy comes first. It doesn't matter which is which in terms of correlation. Now, again, I think that most of the time there is an explanatory variable that does predict the response. So for you to choose them, I think it does matter, but for correlation, it does not. Number 2, the R value does not change when we change the units of measurement of x, y, or both. So again, units of length, inches, the standard system of measurements versus or international standard, whatever, versus, centimeters, which is the metric system. It doesn't matter if you're inches, centimeters, same thing with any other types of measurements. And then lastly, the correlation R has no units of measurement. And again, I emphasize this idea of z-scores, right? They're z-scores, they're standardized. They are no longer in their own unit world. They are unitless. So let's say we can apply these 3 properties. Here we go. So it says, example 2, dash and jump, or jump and dash. The scatter plot shows a relationship between 40-yard dash times and long jump distances. The correlation is R equals negative 0.83, and that makes sense, right? Negative correlation, if I look here, negative correlation because it's a negative direction. And again, that's sort of strong. I mean, they're a little scattered from the linear pattern, but not much. All right, A. What would happen to the correlation if long jump distance was plotted on the horizontal axis and dash time was plotted on the vertical axis? So what they're saying is, what if you took the explanatory of dash time and moved it here? And what if you took the response variable of long distance and moved it there? Well, we just learned the first property. It makes no distinction between the explanatory and response variables. And we're going to write that down. We're going to say the correlation would remain R equals negative 0.83 because correlation makes no distinction between the explanatory and response variables. There we go. Response variables. Sorry, that should be an S. Variables. So the correlation would remain R equals negative 0.83 because correlation makes no distinction between the explanatory and response variables. All right, number 2. What would happen to the correlation if long jump distance was measured in feet instead of inches? So now let's take away the inches and let's call that feet. Well, again, nothing, because it doesn't matter what the units of your variables are. The correlation remains the same. So we're going to say the correlation, and if you want to put CORR just for short, the correlation would remain R equals negative 0.83 because correlation does not change when the units of either variable changes. When the units of either variable changes. Okay. So there we go. All right, and last but not least, here we go. Sabrina claims that the correlation between long jump distance and dash time is R equals negative 0.83 inches per second. Is she correct? So what she's trying to do is she's trying to take the unit of the y, the unit of the x, and go inches per second. And of course we know this is not right. No, she's not correct. The correlation does not have units. Does not have units. And again, I cannot emphasize enough that despite us not using the formula, in the formula there uses standardized z-scores, which means the units go away. Nice. All right. So again, I think that is this last slide. Let's just double check. Yep, sounds good. Objective 3